to structure expert. Today we will start design clinic structure from the structural concept plan architect to finish structural design. Now you see here, it is a structural concept plan architect we got from the client, and the information we got from the client is the we will build for the ground floor, first floor, second floor, and the top roof is use the concrete roof tile, and the ground floor height is 4.1 meter, and the first second floor the floor height is the same, is 3.6 meter. And now we'll start to check from the architectural concept plan. This is not a detailed plan. You see here for the ground floor, it is ground floor, and this one for the first floor, second floor, it's the same. And this one you see here, this is the column for door. You can remove it. It is not important. You can remove it. This column for door, and this is the actual structural column is here. Okay, in this location. Okay, now I just keep in the plan. You see here from this span, from this length is 6 meter length, and this one is 6 meter length. You see, it is a long span enough, so you have to careful with design with this long span. You have to make sure your column section is enough to resist bending moment from the beam, from the slate, and from the extra load, light load. Now you have to check the dimension grid line. Okay, 4 meter, 6 meter, 6, 5, 5, 5, 3, and this one 4. It is available for the ground floor only, but for the next floor, first floor, no this layout anymore. Now you have to check here. Okay, this you check for the clinic. Okay, we have the pharmacy stock, market and pharmacy, consultant, betting space, etc. Now we have to do a pre-dimension for modeling and analysis. Now we come back to our previous tutorial about how to do pre-dimension on elements, but because we have a problem on voice record, it's hard to hear my voice, so now we have to start it again. Okay, now let's open to my Excel set again. You see here, this is the pre-dimension for the OC element. For the beam, you can take the minimum reinforced concrete. Okay, concrete strength 25, slab also 25, cover it here, and this is the thickness of the section for the slab and for the beam. Okay, you see in our previous plan is the maximum length of beam is 6 meter. Okay, now I got the dimension for beam at least is 4 meter, 0.1, at least 0.4 meter. Okay, and you can take the breadth at least half of your height, 0.2, and you can mark up to 0.3 meter. Depend on the rebar you use in this section, is you can distribute this rebar in section or not. So you can take it to 0.6 meter. Okay, for the section of beam. Now in the case I will start from 0.4, and we use more extra sub beam. Okay, and the slab you can see here, this is from the one way to the two way. You can take the minimum is, okay, we use the same, is 6 you can see here the dimension of the slab is at least 150, but you have to make sure the span, okay, you multiply the width and length of the one panel of slab is not over 30 square meter. So now we come back to this one. You see here the width is 6 meter and this one is 6 meter. If you multiply 6 with 6 is 36 square meter. So this area is only okay, you see here 36 meter, okay, 36 meter, 36 square meter is over the limit is 30 square meter. So you have to reduce this slab thickness by reduce slab thickness by adding extra beam. Okay, now we have to reduce this thickness by add extra beam. Okay, now we have to check in this one, and this one is 5 multiplied by 6 is also 30. You can add more one beam, and this one is the same, one beam to reduce the slab thickness. Now we have to start from the floor. Okay, I want to copy it and try to do some sketch on dimension on the layout of the beam. Okay, and this one you can keep this beam one, okay, and this one you can use this beam the same. Okay, now I has to create new color. This is for the beam layout. I just do it quickly. Okay, in this direction, okay, you keep this one, and this direction you keep this one, and this section you keep this one. Okay, and in this direction we keep it on the layout of the wall. Okay, and this is the same, we apply it the same for the grid intersect with a column. Now has to try to do plan layout. Okay, this one you have to move it to the edge of column. Okay, and you have to continue. Okay, this one you can take it at the same, and this one you can take it at the same. Okay, this one. Okay, so in the location you can move it to the middle of the column. It's not specific about the layout of the wall. You can move it. Okay, move it. This one I can keep it for this one, and for this one I also can keep it, but for the design we have to add more. Okay, you have to add more beam to reduce the slab thickness. Now I have to add extra beam on the location. Okay, like this one. Okay, this one. this one, but you can keep it if you like. You can keep it, but you have to extend to add more slab thickness if you don't want to use this beam. But for good recommendation, I have to recommend you, when the slab panel area is over than 30 square meter, you have to add small beam. You have to reduce the thickness of slab and reduce the vibration from the floor. Okay, now you see here, and this one we add other beam. Okay, the same, and this one we add other beam, but you have to make sure this beam is not screw with the stair. Okay, now we have to move it, and the location we have to add another one beam. Okay, this one we have add another one beam to support at the opening of stair, and to support this wall you can add a small section for the beam. I have to copy it again and to copy to the location. Okay, we have to add one beam. Okay, and for other is enough. Okay, now you got the plan layout for the beam. Okay, for the beam, I want to select it and remove some of this not necessary for texture of that. Okay, I select this and select here and delete. Now you can see here it is the plan layout for beam. You see the plan layout for beam. You have one beam direction here, one beam direction here, one beam direction here, another beam in the location of column, and you have to add extra beam. Okay, add extra beam, add extra beam, add extra beam to reduce thickness of the slab. Okay, now we have to come back to the dimension. Now you have the dimension of beam. Okay, dimension of beam, we can take it in the case 0.4 minimum to 0.6 meter, and for the width of beam you can take it half of the height of the beam, and the concrete strength we will take from the minimum here for the beam and slab, and this one you have to check with the torsion. Okay, combine the torsion in the beam. It's not enough for the concrete strength, but in case the concrete strength is not enough, you have to increase it to higher strength, and cover we keep it the same. And now for the slab we will reduce the thickness from here, and now let's continue to the column. We have to talk about three-dimensional column. Okay, now you see here three-dimension of the column. In the case we divide it into part for the short column and for the long column. What we consider about, because we consider about the eccentricity, about the slenderness, about the local effect of our structure, about local effect, about the radius or curvature of the column. Now in the short column you can take it here. You can estimate the circuit load on the column by using the formula I showed you previously on how to do three-dimension on OC element. You can take it and application on your project. Now in the case for the circuit load, you can take it 1 ton to 1.3 ton multiplied with the column area. You will got your estimate circuit load, And for the ultimate load, you can take this vector 1.425. Also, you can make up it to 1.5 multiplied with the circuit load. You will got the estimate ultimate load on the column, and you can predict the rebar and predict the area. Now we had to consider about the long column. In this case, you see here, you can take the load estimate, and after that you can input the 3 dimension, and you will got about the comparison about the sigma stress on your cross section, and this one is must be less than the allowable stress in the cross section. Okay, this is for allowable of the concrete 30 megapascal. Okay, you see here 30 megapascal. So you have to compare with your allowable stress. Applied stress must be less than allowable stress of concrete. Okay, now in the case we have to consider for the long column. Okay, long column, and you don't know about the ultimate exactly, but you have to predict it, or it is not accurate. In the case we have just to explain you how to do pre-dimension. When you just know about some information from the client, you can take it and estimate for the foundation. Now let's start with the column. Okay, now I will start from the column. Okay, from the column. Okay, we had to find the area of the column. Okay, it's enter. Now I have to select the center. Okay, it's again, B again. Okay, this one is the same. Now we have to find the area of column support. Okay, now you have to got this area. Now we want to find the area to predict the circuit load and ultimate load. Okay, this is for the column area. Now we take it as the column area. I call it column area for support load. Now you check on it. The area is 27.5. Okay, 27.5 square meter. Okay, this is your column area. Okay, it's around here. Okay, it's right. Now we let's start from this one. It's 27.5 square meter. Now we have to put it. Now we have to estimate it. For the survey, we use 27.5, and we have to multiply with the number of floor. We have ground floor, first floor, and second floor. We have 3. Okay, we divide by 3, multiply by 3. 3. Okay, 3 down. Okay, is equal 3,000, not kilonewton. This one is not correct, we have to correct it. Okay, and for the ultimate you can do it the same, but you have to multiply with the 70. Okay, you will got the ultimate load for the column is around here. Okay, it's around here. You can verify it with your project to make sure it's correct or not. Now we have some information from the client. We have ground floor, fourth floor, second floor, and top roof. So you have ground 1, second 2, first 3. Okay, 3. You have to multiply the area of column with the 3 and multiply with the estimate load is 1 to 1.3 tons per square meter. Now we have to start with 1.1. Okay, this is the trial. Okay, trial self reload on column. It is for the ultimate. Okay, ultimate load. Sometimes the value can be changed. Okay, now we have to got the 3 values, so you can take this value to calculate the bearing capacity or your soils. You can just got the 3 load, and to predict your foundation you can select a shallow foundation or deep foundation. Okay, it is very important for your 3 load. Okay, now let's start from this load 129 tons. Now we have to predict the section. Okay, we have to predict the section for the long column. Okay, now you got 129 tons from here. Okay, 129 tons, 129 at 1 is a kilonewton. Okay, kilonewton for this one, and for the moment I assume it is 0.25 multiply with this ultimate load. So for the first trial moment, okay, we have to take it as trial load. You can get here. Now we have to compare with the previous. You got the ultimate stress by using the formula. This is the actual stress. It is the stress created by the moment eccentricity. Okay, because your structure will take one moment from the eccentricity and another one from the initial the first order moment analysis. Now I just to add around here to got the ultimate moment on your column. Now you check here with the concrete strength. Now we have select the concrete strength is 30 megapascal, and the allowable concrete strength is 20. Now your section is over than that. Okay, so you have to increase the concrete strength in the trial section. I just concrete it to this one, and you see here this is the allowable concrete strength is 23, and our section is here. Now you have to increase it to 250. Okay, you check it again. Now it's below the limit. and you can choose this one, 350. Okay, in this case the concrete is over. Now we have to keep it the same because our client has to limit the thickness of column. They don't want to increase the width of column, keep it smaller as possible, but you can increase the the height of the column. Okay, so in this case you have to make sure everything is fine. Now we have to just to got about the trial. Okay, trial section. Sometimes this initial section is less than that. Okay, because we have to check input trial section is 20. You got is in no concrete stress, and rebar you can take it 3 or 5% of the cross section or the concrete cross section. It is a trial method. A trial method. Okay, now we continue to the pie cap. After you got the load in the column, you can design the pie cap. You can determine the spacing of pie cap depend on the tie or the ball pie or the driving pie. Okay, you can take it 2.5 to 4 times or diameter or pie. So indicate it depends on the skin friction or unbearing capacity of your pie. Okay, this type of pie is very important effect on the spacing of pie. And for the height, you can take it greater than L divided by 2, and the concrete strength for the pie cap you can take it as the same with the column or higher than column 5 megapascal, and cover is more thicker than column, it around 50. Now you can check here in this one. Okay, you see here, this is the spacing from one pie to other pie, at least 2.5 diameter of the pie, and spacing it depend on the type of the pie, is skin friction or unbearing, because it affect on the soil stress redistribution on the stress or bearing capacity of soil. If you earn pie, you have to take it to 4 times or 3.5 times. But it's skin friction, you can take it 2.5 or 3 times is enough. Okay, this is the overall depth of the pie cap. You can take it must be greater than 8 divided by 2. Okay, spacing from one pie to another pie divided by 2. And for the minimum pie head, okay, pie head to the pie cap at least 7.5 to 30 centimeter. And this one, it depends on your design type or the ball pie with connectivity with the pie cap. If you design a pin, you can take it from here. If you design it fully fit, you can make it to 20 centimeter or 15 centimeter or 30 centimeter. And for the minimum edge, you can take 15 centimeter, at least 15, the minimum. And you see here the layout for the one column supported by 2 concrete pie. Okay, and other case for the single pie, you have one pie. Okay, you have one pie and one column supported by the one concrete pie. So in the case, you can take the dimension or the height. We consider from the pie head to the top of the pie cap. H minimum is much greater than the indicate to make sure your concrete is not crushing. Okay, it's not crushing from the punching, from the extra load. in this trial section, in the trial height, it adequate. Okay, it enough for design. If you has take this height greater than the diameter of the ball pie or of the driven pie, and after that you use the minimum bar reinforcement in this section is enough for the pie with the apply at the center of gravity. Okay, not eccentricity. In the case in for the eccentricity you have to add the beam or add the element to reduce that eccentricity. Okay, I think for the single pie, now we have to share with you about concept, the general concept, and for the minimum age it is the same. It must be greater than 15 centimeter. And this is the overall concept for the concrete strength of the pie cap. Okay, for the cover. Okay, you have to make sure the shear strength in the concrete pie cap is less than design concrete shear strength divided by 2. In the case you don't want to use a stirrup or ceiling. I call it ceiling in a pie cap. In the case you have to make sure that your section is enough, not you a stirrup or you are the link as beam in the pie cap. So this one you use the main bar only. Okay, but in the case this stress is less than that value, you have to add a stirrup or ceiling. For the BS code, you can got the concrete shear stress, by the formula and limit 5 megapascal. And for the Euro code and SI code, this is no upper limit for the shear stress, concrete shear stress, design shear stress. Okay, so for the BS limit the concrete design shear stress. Okay, now we just to got the trial. Okay, the metric strength, certificate, dimension. Okay, everything here. Spacing you can take it 3 times or 2.5 times as the minimum. In this case we have to select it 2.5 times. Okay, now just to compare it. Okay, you can see everything is changed. And for the edge, okay, you see here you have to select the thickness of pie cap is equal to 50 centimeter. Okay, at least you have to select this thickness. Okay, now we have to input it the correct load N5. Okay, where N5 okay, in the case. Okay, we take it from the our trial ultimate load and our trial circuit load to design for the rebar in the pie cap. You see here for the force you can check for the how to design pie cap by using strut and tie method in my previous tutorial. You can check in my channel. Okay, we got here the section of the rebar. Okay, we got here the section of the rebar. it's too small because dvu is kilonewton, so you have to make up with this value. Now I have to multiply it by 10 to convert to kilonewton. It's the same, I multiply it by 10. Okay, you see here, this one is correct. Okay, now you have to check it again. It is the kilonewton. This one also now in kilonewton. So you have to make sure everything is in kilonewton. Okay, this one in kilonewton is correct. And now we have to check the rebar again. Okay, it is our rebar. We had to use at least 14 square centimeter. Now we have to select the rebar, the unit centimeter, or you can input it the millimeter. Okay, now I have to input 1405, and we use this diameter, so you have to use at least 7 okay, 7 dB 16. You can mark up to 8 dB. Okay, so we have to use our dimension of pi now for the pi with two ball pi or with two driven pi. You see here, this is our rear. Okay, rear rebar, rebar area. Okay, the rebar area. Okay, now you got the result. If the h is equal to here. Okay, and spacing u is equal to here. Okay, and the rebar area, insert, save. Rebar area, okay, is equal here. Okay, is equal 8 dB 16, and in the case you can increase it to 50. Okay, 50 centimeter. Okay, now we got the 3 dimension for the pi cap. In case you use 2 pi cap, in case you use 3 pi cap, it's the same. The thickness is not change from this too much. Okay, in the case for the 3 pi cap, you can see here, you can keep the same, but the rebar you can change it for direction. Okay, for direction of pi to pi. Okay, you can change in this direction. Okay, in this direction, okay, and you can use it the same formula apply, and you can take it. Is the load is the same. Okay, the load is the same. Okay, if the load is the same, you can use it 8 DB16, ADB16, ADB16 indicates the strut and tie action is the same. Okay, it is indicate for the strut is the same. We can apply it the same rebar, but indicate if you have the same load, but you add more pi, the rebar will be reduced from here. Okay, from here. Now you got it. And in the case if you use diameter or height or pi or driven pi or driven pi is 13 centimeter. So in the case your height is must be greater than 13 centimeter. Okay, in the case must be greater than this, or at least we have to add more. In the case I round up to 40 centimeter. 40 centimeter. Okay. Forty centimeter. Okay, for single pi. And you use the minimum reinforcement for the top and for the bottom layer. Okay, in the case we use the minimum. You choose the minimum, can group it. Okay, for the top and for the bottom. Okay, you use the S minimum. Okay, S minimum. And the constraint we use the same with this concept. Okay, you can take from the column which you add the same column. Okay. Okay. Now you got here the pre-dimension for your column, pre-dimension for your slab and for your beam, and pre-dimension for the pi cap, 2 pi cap, 3 pi cap, and single pi cap, and pre-dimension for calculating the rebar here. You can see here it is quick. Okay, you can estimate the ultimate load, swing load by using my rule assume. You can apply it. You can check it my previous tutorial about how to do this, about how to do pre-dimension. When you has this one, no has the load. Okay. And this one also don't has. Okay, it has. Okay, has this one. Now we have to run analysis again to check model again. Okay, now we have to perform analysis. Okay, now we have to check about circuit load again. Plan base. You see here, it is the circuit load when we apply the full floor with the same concept in the architectural plan. You see here the estimate load for circuit is 99 kilonewton, and you see here for the estimate is 90. Okay, 90 you can check, and for the ultimate is around 138 ton, and for your estimate is around 130 ton. Okay, you can check here. Now I want to apply the soil spring at this location. We have to assign, and we have to select, unselect, and you have to assign share, and we have to assign the other spring. Okay, you can modify it. Okay, this area spring proportionally is correct. Okay, and apply. Okay, now you have to run it again. We have to check about circuit load again. And we select plan at best. Run it again. Okay, now we have to check about circuit loads again. Okay, now you see here the circuit load is around here. When you apply for the load, now we have to make sure we apply load is the same as not. Okay, indicate for the ground floor we have to apply for this one. Okay, the location is this one. Now I have to untick the floor and select this one, this one, this one, this one, this one. This one. And this one. In the location we skip it because we apply the load already. Okay, this one, this one, okay. Now apply, assign, load, distributed, and we have to assign 16 multiply with 0.1 multiply with 4.1 minus 0.5. Okay, we have to apply it, and for the location we have to apply the load multiplied by 2. Okay. Now we have to run this again. You see here in the column also apply load. Now we have to select it and assign the distribution. We have to delete the load from here. Okay. Now we have correct that. I have to save it and run it again. And we have to check at the best, and we check the reaction again. You see here, it is our predict is 85 down, it actual 85 down, and our predict is 90 down. Okay, 85 down, actual 85 down, actual, and for this one is 90 down for predict or estimate. Okay, for SLI you can check here. It is for the estimate for the survey, and for the ultimate you can check ultimate load is 11 120 down, 120 down, and this one is 129,000. We has some variation between the two view, actual model. Okay, now you can check here what is the difference between the estimate and actual when we apply a model. Thank you for your watching. Thank you.